Okay, today we will solve 5 easiest problems from AIME 1997. Let's start with the first one. So how many of the integers between 1 and 1000 inclusive can be expressed as the difference of the squares of two non-negative integers? Well, it doesn't look complicated. What we're interested at? We're interested to find how many numbers a from 1 to 1000 can be represented as a difference of squares, m squared minus n squared, where both m and n are non-negative integers. And most of people, when they approach this problem, they will try to use this formula, difference of squares. They will tell that a equals m minus n times m plus n. In my experience, this formula with integer numbers works perfectly only in one case, when you know that a is a prime. In many problems, in math competitions, you have the situation when a is 11 or 29, simply a prime number. In this case, a is divisible only by 1 and a, and here is the product of two numbers, and therefore this smaller number should be 1, the larger number should be a, and therefore you have a system of two equations, so that m minus n must be 1, and m plus n must be a. And if you know a, you will able to uniquely identify m and n. So when a is a prime, everything is perfect, but when a is a composite, this formula doesn't give you a lot of information. However, if you spend maybe 3, 4, 5 minutes on this problem, the best approach here is to start from the simplest ideas. In general, I want my number to be represented as a difference of two squares. Well, what number can I obtain if I subtract two squares? Both numbers m and n are like non-negative integers, so if m is 0, m squared is 0. In this case, I should mark 0 as 0 squared. Then 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So we look at this problem as simple as possible. So m and n, some squares, and the question is, what number can I get if I subtract two squares? Well, let's look at these squares that stand nearby. 1 minus 0, m is 1, n is 0, so I can obtain 1. Of course, m should be on the right and n should be on the left, because I want a to be positive. I'm interested only at the positive numbers. If I subtract 4 minus 1, this is 3, this is 5, this is 7, and this is 9. And you immediately see the pattern. The pattern is you can get any odd number. You can get 1, 3, 5, 7, 9, and so on. And if you have some experience at mathematics, it's not really surprising for you. If you participated at math competitions for kids, it's a very common fact that the sum of consecutive odd numbers is always a perfect square. You can prove it as a separate problem. The sum of consecutive odd numbers is always a perfect square. You can use induction to show it, and here you see exactly this pattern. So if you subtract two squares that stand nearby, you can obtain any possible odd number. So any odd number from this range can be obtained just if you subtract two squares that stand nearby. Only you need to find appropriate squares. And therefore, 500 odd numbers from this range can be represented like this. So we have at least 500 numbers. Next, if we subtract any other squares, well, obviously, as we told, m is larger than n in order for a to be positive. So m is on the right, n is on the left. And again, we will use a very common thing. For example, when we look at this difference, this one minus this one, we can represent it as the sum of two differences. So instead of this difference, we will represent that it is equal to this difference plus this difference. And it is also a very common thing to do. So for example, 4 squared minus 2 squared, we subtract two squares, we will represent it as 4 squared minus 3 squared plus 3 squared minus 2 squared. It's also a very common thing. And this is the sum of two consecutive odd numbers. So this one is 7, this one is 5, and the sum is 12. So in general, I can even look at this difference, for example, of the squares that stand not nearby, but just after 1. 9 minus 1 will be 8, and 4 minus 0 will be 4, and 25 minus 9 will be exactly 16. So I can obtain these numbers, and of course you see here the pattern. If you subtract squares that stand like after 1, in this case you can obtain numbers 4, 8, 12, 16, which are all the positive multiples of 4. We can go into more detail just by getting like some more general formulas, but you see just the pattern, and the pattern is obvious. You can obtain that any multiple of 4 by subtracting squares that stay after 1. So how many multiples of 4 do we have here in this range? Obviously we have 250, 4, 8, and so on up to 1000. And in addition to this 500, we also have 250 multiples of 4. Okay, can we obtain something else? Well, let's look at the difference of squares. For example, I subtract this square like minus this square. And again, I represent this difference as this sum of differences, sum of these segments. And we know that if we add two of these, two consecutive segments like this, we have a multiple of 4. If we add one more number here, we will get some odd number. So for example, if there is a difference of 3 segments, we will have here is a multiple of 4, here is an odd number, multiple of 4 plus odd number. Again, we will get definitely odd number, but we already have all the possible odd numbers here. Just if we have one more, it will not provide us any additional information. And if, for example, we have like 4 segments here, this difference is a multiple of 4, this difference is a multiple of 4, and if you add 2 multiples of 4, you will still get some other multiple of 4, but we already have all the multiples of 4 in this range. So it means that if you subtract some square that stays here and some square that stays here, you again represent this difference as the sum of these consecutive differences, and eventually this sum will be whether multiple of 4, sum of multiples of 4, but you already have all the possible multiples of 4, or it will be several multiples of 4 plus odd number, and it will be some odd number, but you already have all odd numbers from this range. So if you subtract any other 2 squares, it will not provide you any additional numbers from here. And this is it. It means that you can obtain exactly 750 different numbers from this range as a difference of 2 squares. As simple as that. So this is it. Let's go to the next problem. Okay, and the next one that we will solve is number 3. Again, it is related to numbers. So what we have here, Sarah intended to multiply a 2-digit number AB, and 3-digit number CDE, and she wanted to multiply these numbers, but she left out the multiplication sign, and she simply placed the 2-digit number to the left of the 3-digit number. So what she have the number that looks like this, thereby forming a 5-digit number. So she made a number like this, and this number is exactly 9 times the product that Sarah should have obtained. So this number is 9 times this product, A, B, C, D, E. And what is the sum of the 2-digit number and 3-digit number? Basically, they want us to find the sum of these numbers. Well, in other words, they want us exactly to find the sum of all these numbers. They want us to find A, B, and C, D, E. In general, when you work on problems like this, it's very useful to get representation like AB equals 10A plus B. Because AB are digits, each of them is an integer number in the range from 0 to 9. Exactly A can't be 0, so it's from 1 to 9, and B is from 0 to 9. So this representation is very useful, of course, for CDE. The representation is 100C plus 10D plus E. And after that, if you represent these numbers in this way, you use the fact that A, B, C, D, these are integers in the range from 0 to 9. In most of cases, it will allow you to solve the problem. However, in this case, if you represent this number, for example, as 10,000A plus 1,000B plus 100C and so on, it will be just a huge expression on the left side, pretty big expression on the right side, and that's not what we need. It will be just like way too voluminous expression. It's not convenient to solve our problem like this. What you should notice here, that here you have a structure A, B, C, D, E. These numbers go like one after another, and here you have pretty much the same. And how can we represent this number? Well, obviously we can represent it as AB times 1000. If you multiply times 1000, you will get AB and 3 zeros at the end. And after that, you can simply add CDE and you will get exactly this number. And it is equal 9AB times CDE. That's what you have here. And you can see here we have 2-digit number, 3-digit number, 2-digit number, 3-digit number. So there is no point for us to leave it like this. We can make our everything way shorter. Just so this one will be A, this one will be B, this one is A, and this one is B. So we have an equation that looks like this: 1000A plus B equals 9AB. A is 2-digit number, we remember about it, and B is a 3-digit number. Let's look at this simple equation. Well, we need to use the fact, of course, that A and B, these are integer numbers. It's super important. For example, we can notice that this one and this one is divisible by B. So with this 1000A can be represented as difference of these two numbers. Each of them is divisible by B. Therefore, 1000A is divisible by B. It means that 1000A has all the prime factors that the number B has, because it's divisible. Is it very useful? Well, in general, not, because 1000 has a lot of prime factors, and it means that some prime factors of 1000 are also prime factors of B. We know which are prime factors, like they have in common. It's not very useful thing. However, if we look from another angle, this one is divisible by A, this one is divisible by A, and again, B can be represented as difference of these numbers, so B should be divisible by A, and this one is already very significant. B is divisible by A, and therefore B equals Ka, where K is some integer number. So B can be represented as K multiplied by A. So let's substitute it here, and we will have an equation: 1000A plus Ka equals 9Ka squared. Of course, now we have A everywhere, so let's divide everything by A, and we have an equation: 1000 plus K equals 9Ka. And here, you see, we have again an equation, and of course, we need to use the fact that we have everywhere here integer numbers. Here, K, and it means this one is divisible by K, this one is divisible by K, and therefore 1000 is divisible by K. And it is a great thing for us, because 1000 has a lot of factors. It is divisible by many numbers, but however, it is not divisible by every number. So if we know that 1000 is divisible by K, then it provides us the range of possible values of K, because 1000 is only divisible by numbers like 1, maybe 2, 4, 8, I'm not sure, not 16, probably 10, 20. I will just write some factors that are in my mind. 20, 40, 100, 250, 500, and this is it. So maybe these are not all the factors, just I don't need all of it, but K should be one of these numbers. It's very important that K should be one of the factors of 1000. It's very important for us. And how can we also save our time? We know that 1000 plus K, this number, equals 9 times something. So 1000 plus K is a multiple of 9, and it means this number, when you add K to 1000, it is divisible by 9, and therefore the sum of the digits of this number is divisible by 9. So for example, K can be equal to 1, because it's like a multiple, it's a factor of 1000. If K equals 1, let's try to substitute here. 1001 here, is it divisible by 9? No, it's not, because 1001 has sum of digits 2, not divisible. So K equals 2, so let's substitute here, it will be 1002, and again, not divisible by 9, so it doesn't work for us. And here you can see that 8 will work. 1000 plus K, it is 1008. It is obviously a multiple of 9, because 1 plus 8 is 9. And in this case, everything looks like it will work out. Let's check. Let's check that it is like a working option for us. If K is equal 8, in this case, we have an equation here. 1008 equals 9 times 8, 72A. what would be the value of a? In this case, a equals 1008 divided by 72. Let's quickly divide it. 1008 by 72 equals 1 minus 72, 28, 8, and it will be 4. So 14. It means that a equals 14. And what would be the value of b? So let's go up and see that b equals Ka, right? Because b is divisible by a, and we told that b equals Ka, and therefore b equals Ka 8 times 14, and it is equal to 112. So a equals 14, b equals 112. Looks like everything works for us perfectly. If you want to make sure that you are like correct with your answer, if you have a minute, what you should do, you should go just to the beginning of your problem, right at very start, and to check that this equation is true, you should substitute here instead of AB 12, instead of CDE like 112, and to check that it's really true, that this number is 9 times 12 times 112. It is the best option to make sure that you didn't make any mistake. And this is it. And of course, we need to find the sum of 2-digit number and 3-digit number. So the sum will be here 126, and it is the correct answer for our problem. So, and also a great point. We found here that k equals 8 work for us, and after that we found the appropriate values of b. The main question for you, do we need to check any other values of k? Not in AIME competition. AIME is very time limited, and here when you solve the problem, if you found some option that works for you, and after that you got a perfect answer, everything works out, this is it. It's not the math competition like British Math Olympiad or any other math competition where you need to make a research, to consider all the possible scenarios, to show that only these scenarios work for you and others don't. Here, if you found the right answer, if you found the right approach, and you see that everything works out, this is it. You don't need to make any sort of research to prove that other answers do not work for you. You found appropriate key, found A and B, got the right answer, got the answer, and you check that everything is right, and you move forward. And we are moving forward. Okay, and the next one will be geometry. Let's look at number 4. So 4 is very short and in the same time very interesting problem on geometry. You have circles of radiuses 5, 5, 8 and m over n that are mutually externally tangent. So 4 different circles mutually externally tangent. You know here radiuses of 3 of these circles, and this one is obviously unknown. The radius of 4th circle is unknown. You are told that m and n are relatively prime positive integers. You need to find m plus n, but in other words, you simply need to find what is this value, what is the radius of the 4th circle. And looks like a very short problem. Let's try to make a picture that reflects the situation that you have 4 circles that are mutually externally tangent. Let's start from the first circle, the circle with radius 5. So it should look like this, the circle of radius 5. Another circle of radius 5 is tangent to this one. So let's draw another circle like this one. So it will be also of radius 5, and these are tangent circles, and the other circle has a radius 8, and again it is a little bit larger, and it should be tangent to both of these circles. Very important. So because once again they are mutually externally tangent, so it should be like this. And we are left with only one circle with radius m over n. It should be tangent to each of these circles. Where can it be located? Can it be located here? Obviously not, because there is no tangency with this one. It can't be located here because there is no tangency with this one. The only possible position for this circle is to be like here. So in this case, it will be tangent to all of these circles. So let's mark this position, and let's try to make here, let's try to draw a small circle here that is tangent to other circles. Let's try to make like a small circle with red color that is tangent. So let's try, and well, almost, just maybe a little bit smaller. Just let's make circle like this. Maybe it will work out. Just a second, and yeah, fits almost perfectly. So this small circle has a radius m over n, and it is tangent to these 3 circles. We need to find its radius. When you have circles that are tangent, super important thing that you always should remember. 3 points always belong to the same line. Center of the circle, and the point of tangency. And let's use it in this problem. So here, center of the circle, and the point of tangency are on the same line. The same for two of these. Center, point of tangency are on the same line. And here also center, point of tangency. So this circle has a radius 8. So this is 8, this is 8, this segment is 5, this segment is 5, this is 5, and this is 5. So you can see here we already have an isosceles triangle. But eventually, we need to find the radius of this small circle. It is located somewhere here. And of course, we should use the same fact. For example, this center, and the point of tangency are on the same line. Let me draw the line here. Okay, and again, this center, and the point of tangency are on the same line. So let me draw a line like this. Well, it doesn't make any sense for me to connect this center with this one, because here I will get exactly the same triangle as here. I will not get any new information from it. So here, this segment is 8. This segment is exactly 8. And what about this one? We have here this writing that this radius of small circle is m over n, but it's very inconvenient to work with this fraction all the time. So it makes a lot of sense to introduce this unknown radius simply as x. This is also x, and this remaining segment is 5. So here we have a very simple problem on geometry. We need simply to find x from this picture. Well, what we see here? We see that the situation has like complete symmetry with respect to this line. Because really, this circle has a radius 5, this circle has a radius 5, it is 8, and this line goes exactly like in between. So it will go exactly to the point of tangency of these circles. AIME, now we are solving geometry from AIME. It's not a classic competition in geometry or other math competition where you need to prove like everything precisely. In some math competitions, you need to justify why there is a symmetry. But here, if you see the symmetry on the picture, you immediately use it, because the only thing that is important here that you will come up to the right answer. So your reasoning, it shouldn't be like super perfect. You shouldn't prove everything in detail. You see that there is obvious asymmetry here. So this line should pass exactly through this point where these two circles of radius 5 touch each other. So it means that this one is a median in isosceles triangle, and therefore it's also an altitude, it's a perpendicular, it is also an angle bisector, and therefore you can find this angle alpha. From this right triangle, you see that sine of alpha equals 5 over 13. If you are familiar with the right triangles, 5 and 13 are very good numbers, because if you try to calculate what would be the cosine alpha, it would be exactly 12 over 13. You just use the formula that cosine square alpha plus sine square alpha equals 1. And by the way, if you solve the problem and you get numbers like this, and sine is pretty good, cosine is pretty good, it is a great indication that you are probably in the right track. So you found the angle alpha, and now you look at this triangle and you simply apply cosine law for this triangle. And here you have cosine alpha, you have some sides. Let's apply it, and we'll have an equation simply for x. So the square of this side, which is 5 plus x squared, equals the square of this one, 8 plus x squared, plus square of this one, which is 13 squared, it is 169, minus 2 times this one, times x plus 8, times cosine, times this one, let's also mark it by this one, minus double product of these sides times cosine alpha, which is 12 over 13. So, and here we applied cosine law. So the square of this side is this squared minus double product of these sides times cosine alpha. Great. So here we have that this 13 simply cancels out. Great. And we have a normal equation. Let's solve it. 25 plus 10x plus x squared equals 64 plus 16x plus x squared plus 169 minus, and here we will have 24x, 2 times 12, 24x, and here we'll also have 24 times 8, 24 times 8 with minus sign, so 24 times 8, what will be the result? It will be 192, so it will be minus 192. Well, the good news for us here that x squared on both sides cancels out. What else? Does something else cancel out? Well, doesn't look like this. Let's bring everything with x to one side and everything with numbers to the other side. So this 10x goes here, and here on the right side we have 16x minus 10x. Well, we'll have negative value of x, but this is it. So we'll have 16x minus 10x, it will be 6x minus 24x, it will be minus 18x on this side. No problem. So we'll leave it like this. And with numbers, we'll bring everything to the other side. So here we will have 25 minus 64, 25 minus 64, minus 169, minus 169 plus 192. So for me here it's already inconvenient to work with negative numbers. I will simply multiply everything by minus 1 and I will get 18x equals 169 plus 64 minus 25 minus 192. Well, this one is way better. Great. So what is this sum? It is equal to 220 plus 13. It will be 233 minus 25 minus 192. So this difference here, 233 minus 25 is 208. 208 minus 192, and this difference is exactly 16. So 18x equals 16, and therefore x equals 16 over 18 equals 8 over 9. So it makes a lot of sense to reduce this fraction, so it equals x 8 over 9. So this radius here is simply 8 over 9. And here we are told that this radius is like a fraction, m over n, and m and n are relatively prime positive integers. Of course, 8 and 9 are relatively prime for us, and we need to find m plus n. Well, in our case, the sum of these digits is simply 17, and 17 is the right answer for our problem. As you can see, the solution was pretty short and it's not a complicated problem. The most difficult part here is simply to come up with the right picture. This is it, so let's go to the next one. Okay, let's solve a simple problem on geometry, number 6, very short one and an interesting problem. The point B is in exterior of n-sided polygon A1, A2 and so on an. So let's make a picture right away. We have a regular polygon that looks like this, A1, A2, AN. So the general form will be like this, and there is a point B somewhere in exterior, so somewhere here, such that A1, A2B is an equilateral triangle. So A1, A2B, so A1, A2 are consecutive vertices. It means that the picture should look the same. For example, A1 here, A2 here, and B is an exterior, so this is an equilateral triangle. So it's A1, A2, and here should be like A3, A4, and so on. And here the vertex is AN, right? Because there is like a full cycle here, AN, A1, A2, and the picture is like this. This is equilateral triangle, and of course all the sides of this triangle are equal. This is 60 degrees, and this side is in the same time the side of this regular polygon, so the picture looks like this. And what we also asked, what is the largest value of n, the largest value for the vertices of this polygon, such that AN, A1 and B, AN, A1 and B are the consecutive vertices of a regular polygon. Probably some other regular polygon. So there exists some other regular polygon such that AN, A1, and B are consecutive vertices of another polygon. Well, the idea is very simple. if there is some other regular polygon, the angle of this polygon, AN, A1, B, should be like very of proper amount. It's very important because regular polygons, they can't have like any angles. For example, regular pentagon has every angle of 108. A regular hexagon has every angle of 120. So if we want some other regular polygon to exist such that AN, A1, and B are consecutive vertices, then this angle AN, A1, A and B should be precisely the angle of some probably other regular polygon. However, I have several questions here. At first, in our picture, everything looks like one line. So let's make like a little bit different picture, so it will be not like a line. So it is our regular polygon. The point B is here. And so we are looking at the vertices A1, A2, here we have B, and here we have AN. So these three vertices are vertices of some other regular polygon. So this is 60. What is the angle here? So we know that the sum of angles of polygon with n sides is 180 times n minus 2, but for regular polygons, all the angles are equal, and therefore we have this formula. So each angle of the regular polygon with n sides is like this. So this total angle probably should be the angle of some other regular polygon with k vertices. So let's make an equation. So 60 plus 180 times n minus 2 divided by n should be equal to the other regular polygon. If it goes like this, each angle of another polygon will be 180 times k minus 2, because it has k vertices, divided by k. And we should work here with this equation by taking into account that k and n are integer numbers. However, for example, if I look at particular cases, like for a hexagon, this is 120 for hexagon, this is 60, so it is already a straight line. Of course, there is no other polygon that goes like this, because this angle is 180, there are no polygons with angles 180. But what you need to notice that after 6, when n is larger than 6, this angle will be larger than 120, because from this formula quickly follows that the larger the amount of vertices, the larger the n, we have the greater the angle of the polygon. And if this one is greater than 120, this one is 60, so it means that this one will be larger than 180 for any n greater or equal to 7, and there is no regular polygon that goes like this. So this angle, the remaining angle, will be less than 180, because this one is larger than 180. And we should look to the regular polygon on this side, to the other side. It's a very important point for us, because what we are looking here, we want to find the largest value of n. So we want to find n as large as possible. And here we see that as soon as n equals 7, this angle is larger than 180, and this angle will be less than 180. So n is greater or equal than 7, then this polygon that we are talking about, it should be on the other side. And the angle of the polygon should simply complement these two angles to 360 degrees. So the angle of the regular polygon plus these two angles should be 360 degrees in total. And therefore, our formula should look like this, because we are interested at these values of n. Even if we find that something exists for n equals 4, for n equals 3, it's not enough for us. We're interested to look at the large values of n, because we need to find the maximum value of n such that this situation like works out for us. Okay, so in this case, we will have 60 plus 180 times n minus 2 over n. It will be the angle of my polygon plus 60 degrees. Let me make a little bit more realistic picture. So the angle of my polygon will look like this. And here we have also the angle of 60 degrees. The sum, as I told, the sum of these two angles is larger than 180. So therefore, the regular polygon that we're talking about, it goes like this. It goes like this, it goes like this. And the angle of this regular polygon complements these two angles to 360. So it means that we can write that plus 180 times k minus 2 over k equals 360. Perfect. We have a simple equation here, but n and k, very important, integer numbers. So it means that 180 n minus 2 over n plus 180 k minus 2 over k equals 300. Immediately I want to divide everything by 60, so it will be 3 times n minus 2, 3 times n minus 2 over n plus 3 times k minus 2 over k equals 5. And after that, I multiply everything by nk. So we multiply everything by nk. And what we have here, just a second, we will have 3n minus 2 times k plus 3 k minus 2 times n equals 5nk. Let's work a little bit with this equation. 3nk minus 6k plus 3nk minus 6n equals 5nk. And here we have 6nk. Let's leave 6nk here. 5nk will bring here, and other numbers will bring to the other side. So we'll have here nk equals 6n plus 6k. And what we are looking here for? We are looking if this equation has a solution in integer numbers n and k, and we are interested to make n as large as possible. If you have an experience at math, it's very easy to work with these equations. Of course, you should never try to guess some numbers. Here you will spend just huge amount of time. You should factorize it, and then you will use the fact that here you work with integer numbers. How you can factorize it? Well, you do it just generally by looking at the expressions like maybe 6 minus n, like maybe 6 minus k. If you multiply it, what will you have? You will have here 36 minus 6n minus 6k plus nk. It will be pretty similar to this one. The only thing that you will have to subtract 36 and make it equal to 0. So does it work for you? For example, if it's 36 minus 36, 0, minus 6n minus 6k, so it will be with minus 6n minus 6k if you multiply it. And after that, you will also have plus nk equals 0. And if you bring this one to the other side, you will have the equation that looks exactly like this. So it can be rewritten in this form. It can be written like this, but what I want here, you see, I'm looking at the big values of n. And so for me, it's not convenient to work with 6 minus n, because now immediately I know that when n is larger than 7, it is a negative number. I don't like negative numbers, so I can just multiply here everything by minus 1 and here everything by minus 1. The product will not change, but instead of this, I will have here an expression. I will have n minus 6, n minus 6, not 6 minus n. It's just better because it will be positive. And k minus 6 minus 36 equals 0. So this equation is equivalent to n minus 6 times k minus 6 equals 36. And now you can solve it very simple, because you see that this is integer, this is integer, the product of two integers equals 36. Well, you can represent 36 only like in so many ways as a product of integers. You immediately know what are the possibilities of n and k. However, here it's even more simple. You are interested to make n as large as possible. Therefore, this factor n minus 6 should be maximal, should be as large as possible. What is the value of this maximum factor here? Well, obviously, this one should be exactly 36, and the other factor here should be exactly 1. So this one should be 36, and this one should be 1. In this case, n minus 6 equals 36, and k minus 6 equals 1, and therefore n equals 42, and k equals 7. It is a proper and correct solution of this equation, and you can go up and you can see that everything we did here was pretty much equivalent. So from this equation, you can easily go back to your initial equation. We didn't do like anything extraordinary, so everything was, all the transitions between equations were pretty much equivalent. So therefore, n equals 42 and k equals 7 is a solution for your problem, and therefore n is a maximum. option for you. And the conclusion is that when you have here a regular polygon with 42 vertices, and if you have here this equilateral triangle with 60 degrees, the remaining polygon here that you can draw will be a polygon with 7 vertices, and the maximum value of n is 42, and 42 is an answer for your problem. This is it. Okay, and the last problem that we will solve today is a problem number 7. It is an amazing one. It's the best that I have seen in AIME. Just a great problem. So a car travels due east at 2/3 miles per minute on a long straight road. Okay, once you have these directions, due east, due north, it makes a lot of sense to make like a small diagram, so you will not be confused with directions. So I make a cross, and after that we mark north, south, west, and east. So initially you are told that you have a car that travels due east, so directly to the right, with this speed. So let's make a picture. So there is a car that travels, let me take a little bit more space on the left, so maybe like this. There is a car, it travels due east, so it starts somewhere here, and it moves to the right with the speed 2/3 miles per minute. Well, good enough, so everything is clear. Then what we are told, at the same time, a circular storm whose radius is 51 miles moves southeast. Southeast is like this. Here is a 45-degree angle with the speed 1/2 square root of 2 miles per minute. So, and it's very important, at the time t equals 0, the center of the storm is 110 miles due north on the car. So at the time moment t equals 0, the center of the storm is here. Okay, let me just use probably black color here, and we will mark the center of the storm right above, because due north, right? The center of the storm 110 miles due north of the car. So it will be like here, the center of the storm. Let's mark the point here, and this distance is 110 miles, and the radius of this circular storm is 51 miles. So the radius, if the center is here, the radius is almost like a half of this distance, and it means that we have to make a picture to draw some circle. It will be this total circular storm, and let's make it like this. So this radius is 51. So let me mark here that this radius of the circular storm is 51. Better on the other side where we have distances. So this is 51. And after that, we will also have to mark the speed of this storm, because it moves southeast with this speed 1/2 square root of 2. So let's make like a vector here, and you obviously understand that this angle should be 45 degrees, and this speed is 1/2 square root of 2. Once again, we are doing math here, we are not doing physics. In physics, it's very important to convert all your velocities, speeds into meters per second, but we are doing math, we are very fine with meters per minute. So it is the speed of your storm, and it is the speed of your car. So, and in this case, we also have directions. So it means that we have even vectors. So we can speak about velocities. And the main question, at the time t equals t1 minutes, the car enters the storm circle. How it happens? The storm goes like this. The car goes like this. At some moment, car goes into this circle and into the circular storm, and after that they move, the circle is moving, the car is moving, but the car will be inside the circle for a while, and after that, after a certain amount of time, the car will exit the circular storm, and it will be at the time t equals t2 minutes, and you need to find the arithmetic mean, the average between these two times, between t1, when car enters the circular storm, when they meet, and after that, when the car exits the circular storm at the moment t2, you need to find the arithmetic mean of these numbers. So this problem, I consider this one as very interesting, and in general it's a great problem in mathematics, that if you try to solve it like in a simple way, just by looking at the motion of this circle and the motion of this car, it will be very difficult to do. You can try to make some assessments by yourself. It will be very difficult to understand at what time moment a car will enter the storm, when it will exit, and so on. It will be just a mess. However, it's very important to remember the concept of relative velocity. So here is the absolute speed of the car. We will call it velocity because we work with vectors. The absolute velocity of the car with respect to the ground frame. The ground frame is here. Here you have y-axis, and here you have x-axis. And it is the velocity of your storm. So for us, it's very important when car enters the storm. So the storm is like a moving circle. Let's make this one as a moving frame. Each one is a moving frame. And this one connected with the ground will be ground frame. And we have a very simple formula from physics, and it is that absolute velocity, v absolute, it's v of the frame equals v of the frame, so it means that v of your moving frame, moving system, plus the relative velocity of an object with respect to this moving frame. So how it works? I have a car. The absolute velocity of the car with respect to the ground frame equals the velocity of this moving frame, this vector, plus the velocity of the car with respect to this moving frame. It's a basic thing from physics, and if you are familiar with physics course, it's a very important one. What does this formula allow us to find? Here we know this one. We know this one because it is like the speed of the storm, and we should work here with vectors. We will be able to find the velocity of the car with respect to this moving storm. And what it allows us to do in practice, that once we know this velocity, we can reformulate the problem. We can simply jump here in the center of our moving storm, so the observer will stay here, and he will assume that this storm doesn't move at all, so this circle stays the same. The only car is moving, and because really, if you are sitting, like for example, inside the storm, and you are moving together with the storm doesn't move with respect to you. You are like standing still here. However, you only will see from this storm, if you are moving with the center, that the car is moving towards your direction, and after that it will intersect and it will go out, and a car will move with this relative velocity. It's a very common approach to change the frame. So the motion of the car will stay the same, the time intervals will stay the same, the distances will stay the same, but from here we will look at the motion of our car. It will look differently. There will be different trajectory, there will be different velocity, different acceleration. It's a very common approach, like in physics, to change this, to jump into some like moving frame and to look at our motion from some moving frame, because in this case the motion will look way simpler, and you can see it here, but the main properties of the motion will stay the same. Because, like for example, if the car is moving on the ground, and in the same time, for example, let's assume that you are flying on the plane and you are looking from the plane to the moving car. Of course, from the plane the motion of the car will look very different for you, right? It will have different trajectory, different velocity, different acceleration. However, all the property related to the motion of the car will stay the same. Time intervals when the car needs like to pass between certain points will stay the same. The distances that car needs to travel stays the same. So the main properties of the motions will stay the same. The only thing that from the plane you will see this motion like it's going in a little bit different path. And this is it. And that's what we will do. We will jump here into the moving frame. Let's find this relative velocity of the car with respect to this storm. So this vector, absolute velocity, has components 2 over 3 and 0. This vector has components, this velocity of the moving frame. If you make like projections to x and y, this one, v of the frame, has components 1 over 2 and 1 over 2. Let's check if we multiply it. Yeah, it's great, but for x this component is positive, but for y this component is negative. So it will be like this. Perfect. So it is the components of the absolute velocity of this vector, and these are the components of the velocity of your moving frame. Because when I work with vectors, for me it's way easier to work with them by using their coordinates, because it's way simpler. So the relative velocity of the car, v relative, equals the difference of these vectors. When I subtract vectors, I simply subtract their coordinates. So it is equal to 2 over 3 minus 1 over 2. It is equal to 2 over 3 minus 1 over 2, it's 1 over 6. So the first component is 1 over 6, and the other component is simply 0 minus 1 over 2, 1 over 2. So it is a relative velocity of the car, and let's now reformulate our problem, and we will make absolutely equivalent picture. So now we are looking at the car from the center of our storm. So the storm is located here. Just a second, the storm is located here as it was. Let me just put it on y-axis. The initial distance between the center of the storm and the car is still the same. So the distance doesn't change. So this initial distance is 110. The radius of the storm, of course, doesn't change. So this distance is still 51. Let me make a radius like this. So I will just mark it like this. So it will be 51. However, the velocity of the car 1 over 6, 1 over 2. So now it moves like this. So this vector should be directed like this, and because you can see, right, x component is 3 times smaller than y component, and therefore the direction of this velocity is something like this. Okay? So it is a relative velocity of the car. Let's tell that this vector is 1 over 6 and 1 over 2. And here we may assume that we have an observer at this point at the center of the storm. And for observer, it looks like the car travels to the storm like with this velocity. And what will happen? Now it's much easier to imagine that if the car goes in this direction, eventually it will enter the storm. Here it will go inside the storm, and after that it will exit. So now from the point of the observer that is located at the center of the storm, the picture looks super simple. For him, the storm stays still, nothing moves, but the car is traveling like this with relative velocity to the storm. It intersects it, it goes inside, and then it exits. So this time moment when car enters the storm, it happens at time moment t equals t1. Here the exit of the storm happens at moment t equals t2, and we're interested at find 1 over 2 t1 plus t2. It is just a part of our problem. So let's look at the geometry, what we know. We know that these 2 points of entrance and exit of the car, they are located at this circle. So it means that this distance is 51 and this distance is 51. So let's look at this is 51 and this is 51. So what can we find here? In general, we would like to define somehow this triangle. Well, there is no problem to find angles here. For example, this is 90 degrees. If it's the angle of inclination for this vector, 1 over 6, 1 over 2, this angle has a tangent 1 over 2 divided by 1 over 6. It's y component of the vector divided by x component. It's 3. The tangent of this angle, let me mark it, for example, as alpha. So tangent of alpha equals 3. This angle, another one, here beta, it complements angle alpha to 90 degrees. And therefore, their tangents are reciprocal numbers. And therefore, tangent beta is 1 over 3. It comes from a very simple fact that if alpha plus beta is 90 degrees, then tangent alpha is cotangent beta, and so on. It's like similar for sines and cosines. You have this basic formula, and just the short implication of this formula that if the sum of 2 angles is 90 degrees, then their tangents are reciprocal. So tangent of this angle beta is 1 over 3, and you pretty much know the direction of this ray, how it will enter to this circle. You know the radius of this circle. In general, you can find this distance, for example, B. You can find the distance AB, and to divide it by the speed of your car, how to find the speed of your car? It will be simply the length of this vector. And the length of the vector with components 1/6, 1/2 is 1/36 plus 1/4. Square of this component, square of this component. And this sum, you can multiply here by 9, equals square root of 10 over 6. It is the speed of your car when it's moving along this ray. And in general, you can find T1 by looking at the distance AB. You will find this one, and you will divide it by the speed of the car. And you will find T2 by getting the distance, for example, AM, and you divide it again by this speed. And after that, you can work with this one and this one. But if you try to do it by yourself, if you try to solve this problem in this way, just to explicitly find AB and AM, you will find out that it is not very easy, not very complicated, but not very simple. But it takes a lot of time. You will not get good numbers. So the key here to notice amazing thing that you need exactly arithmetic mean of these time moments. Car is moving along this line with a constant velocity. You need exactly time moment in between this number, arithmetic mean of T1 and T2 is exactly in between. So we need time moment exactly in between these time moments. It means that at this time moment, the car will be exactly in between these 2 points. So it will be exactly in the middle of the chord MB. So it will be X, the position of the car, at the moment 1/2 times T1 plus time 2, because this is in between. And what is the midpoint of the chord? Basics of geometry, you know that the middle of the chord is located here, should be a perpendicular. If you connect the midpoint of the chord with the center of the circle, this one is a perpendicular, just very basic thing. And now you can look that here, this triangle, for example, HAX, is a right triangle, and you know here hypotenuse, HA, and you know here angle beta. You know that the tangent of beta is 1/3. It means that you know basically everything about this right triangle, because you know the angle and hypotenuse, which is amazing thing. Okay, so how can you find here, in this case, AX? Because we're interested at this distance. AX equals, so for example, AX equals, you can work with sine of beta. Well, if we know, for example, tangent, let's make it like this. Tangent beta is 1/3. It means that this HX divided by XA is exactly tangent beta. It's 1/3. It means that we can make variable HX will be Y and XA will be 3Y. So we have a triangle that looks like this. This is 110, this is Y, and this is 3y, and angle beta is located here. So let's use Pythagorean theorem here. In this case, y square plus 9y square, the square sum of squares of legs, equals 110 square. So let's find y from this equation. In this case, 10y squared equals 110 squared. So let's write it like this. 10y squared equals 110 times 110. I divide both sides by 10. Here just 0 cancels out. And I have y squared equals 121, 0. Okay, so 121 is 11 squared. So y squared equals 11 squared times 10. And therefore, y equals 11 square root of 10. Great. Y equals 11 square root of 10, and we are interested at this distance AX, and this distance AX is simply 3y. Therefore, AX equals 3y equals 3 times this one. It is 33 square root of 10. It is this distance, and if we divide this distance AX by the speed of the car, which is this one, so AX divided by the speed of the car, which is 33 square root of 10, divided by 10 square root of 10 over 6, if we perform this division, we divide distance by speed, we will get exactly time that is needed for the car to reach from this point to this point when we divide distance by the speed. So, and it will provide us exactly this time moment when car is at this position. And after that, we will get the result 198. 198 is the correct answer. So this number is 198. And it is the answer for our problem. So I consider this problem as just amazing because at first it is like very unusual way of thinking. You need to use very like interesting methods to solve it normally, because if you try to solve it directly, you will encounter a lot of problems. And this idea that you should basically jump into the moving frame, into the center of the storm, and to look to the motion of your car from the position of observer that is located at the center of the storm, to understand that in this case the car will move like this and the storm will be like in a fixed position. It's a very interesting and very unusual idea. And in addition, even after that, when you apply this idea, it's not enough to completely solve the problem. You should look here at the geometry, right? So the geometry here will help you to find the needed time moment, because if you try to find T1 and T2 in a very direct way, you will encounter that you will not have like a good numbers, and it will be just a little bit time consuming. However, this simple idea that if you need time moment in between, the car will be in between, it will help you to get this right triangle and to get like answer in a very fast and efficient manner. So it's a great problem. And so I hope I'm not the only one who thinks like this. So thank you, and this is it for today.